In Unit 3, we are discussing the circuit analysis techniques, nodal analysis and mesh analysis. Nodal analysis is based on Kirchhoff's current law and mesh analysis is based on Kirchhoff's voltage law. Already in Unit 2, we have discussed Kirchhoff's current law and Kirchhoff's voltage law. Nodal analysis is completely based on Kirchhoff's current law. All the nodal equations we are writing on KCL. Nodal analysis actually provides a general procedure for analyzing the circuit using node voltage as circuit variables. Choosing node voltages instead of element voltages as circuit variables is very convenient and it reduces the number of equations that must solve simultaneously. So in nodal analysis, we are interested only in finding the nodal voltages. Given a circuit with n number of nodes, we will be having n minus 1 unknown voltages. So if we have given a circuit with n number of nodes without any voltage source, that means your circuit contains only current sources and resistors. Then for doing the nodal analysis, these are the steps we need to follow. The first step is identify the number of nodes. First we have to see how many number of nodes are there in the circuit, including the reference or ground node. So total number of nodes we have to identify first, and second step, bottom node take as the reference node. So the ground, normally we'll say the ground. So all the ground take it as a common node and it is called a reference node. And the third step, redraw the circuit for convenience. Here is the step we are drawing the nodal diagram. And fourth step, we have to assign the node voltages. So how many, suppose we have 3 nodes, 2 nodes will be the non-reference node and 1 is the reference node. So corresponding to the 2 non-reference node, we have 2 unknown voltages. So we have to assign the node voltages for that. And the fifth step is we have to apply the KCL to each non-reference node and solve the system of equations. So these are the 6 steps we need to follow for the Kirchhoff nodal analysis. So for better understanding, we'll do an example problem. See the problem. You have to obtain the value of unknown voltages across various symbol elements. Here we have 1, 2, 3 resistors and 2 current sources. We need to find the voltage across these elements. See, the voltage across the current source will be the voltage at this point with respect to ground. Even 2 ohm also same. 1 ohm means voltage at this point with respect to ground. Minus 1.4 ampere source means voltage at this point with respect to ground. 5 ohm resistor means it is a difference in voltage between this node and this node. So we need to find these voltages. So as a first step, what is our first step? Our first step is to identify the number of nodes. How many nodes are there we have to identify. So just see here how many nodes are there. This is an element, this is an element, this is an element. All these meeting at this point. A node means a point where 2 or more circuit elements meet. So this point we have 5 ohm resistor, 2 ohm resistor and 3.1 ampere source meeting. Now see this point. Here we have 5 ohm resistor, 1 ohm resistor and this current source. All this meets. So we have two nodes here and all these elements are grounded at this point. So that is taken as the another node. So total we have three nodes are there. So going to our first step, identify the number of nodes. So now we have identified the number of nodes as node number 1, 2, 3. So 1, 2 and 3 number of nodes. Now go to the second step. Second step is take bottom node as the reference node. So this is the bottom node or the ground node. Take it as the reference node. So this is the reference node. Now the third step, redraw the circuit for convenience. See, here we have to draw the nodal diagram. As we are doing the nodal analysis, we need to project the number of nodes more and based on nodes should be more projected in the circuit. So draw the nodal diagram of this circuit. Nodal diagram. First draw what are the nodes that alone. So one node here, that is node number 1, then node number 2 and node number 3. So node number 1, node number 2 and node number 3. Between 1 and 2 we have a 5 ohm resistor. So between 1 and 2 we have 5 ohm resistor here and between 1 and 3 we have 2 ohm resistor. Between 1 and 3 we have 2 ohm resistor. Between 2 and 3 we have 1 ohm resistor. So between 2 and 3 we have 1 ohm resistor and this is 2 ohm. Now between 1 and 3 we have a current source and the current source marked as which direction? Upward direction. So mark it as upward direction between 1 and 3. It is 3.1 ampere. Now we have between 2 and 3 we have another current source marked downward direction. So between 2 and 3 we have a current source marked in downward direction as minus 1.4 ampere. So this is the nodal diagram of the circuit. See now the circuit we are projecting mainly only the nodes and with the nodes we are drawing all the elements connected to it. See here node 1 we have 3 elements 5 ohm, 3 ohm and this current source. Node 2 we have again 3 elements 5 ohm, 1 ohm and this current source. So now our fourth step is we have to assign the node voltages to each non-reference node. So next step is we need to assign the node voltage for each non-reference node. So this is one node. So here I am assigning the node voltage as V1 and this non-reference node I am assigning the voltage as say V2. So V1 is with respect to the bottom node or ground, V2 voltage also with respect to the bottom node and ground. Now our fifth step, we have to apply KCL, Kirchhoff's current law to each node. So when we are applying KCL, how many number of non-reference nodes are there? That many number of equations we need to get. So that many number of times KCL we need to apply. So here two non-reference nodes are there. So we need to apply the equation for this node as well as KCL for this node as well as this node. So first at node number 1 when you are applying the KCL, assume that all the currents are leaving the node. Assume that all the currents are leaving the node through the resistor. So here the current is leaving, here the current is leaving. Here the current is entering as per the given direction. current source, we have to consider the given direction. So here, when I am considering for the node 1, see here we have the first current leaving it this branch. So that one is we can write as the current through that branch is V1 divided by 2 because this is 0. V1 divided by 2. Now this branch it is plus V1 minus V2 divided by 5 ohm. Now the third branch on this ending with this node is this current source. Here see these two currents are leaving but this is entering. So should be minus sign minus 3.1 should be equal to 0. So it is V1 divided by 2 plus V1 minus V2 divided by 5 should be equal to, take it to the other side, it is 3.1. Now, this equation is difficult to solve. So, take the LCM and make it only one, means no numerator and denominator separate, make it only one element, numerator alone. So, then it becomes, take it LCM 5 into 2, 10. In 10, how many times 2? 5 times. So, 5V1, simple mathematics. Now, this is 2 times. 2 into V1 minus V2 should be equal to 3.1. Cross multiply it, we will be getting it as 5V1 plus 2V1 to multiply inside 2V2 should be equal to 31. 5 plus 2, 7 times V1 minus 2V2 is equal to 31. So this will be the equation corresponding to nodal equation corresponding to node 1. So mark it as equation number 1. So this is the first equation. Mark it as equation number 1. Now go to the node 2. So when we are considering the KCL for node 2, assume that all the currents are leaving from node 2 through the resistors. So we will be writing the equation as, and this is a current leaving as shown in the direction same for the current source. So it is V2 divided by 1 plus, for this we'll write it as V2 minus V1 divided by 5. And the other one is also leaving, so it is minus 1.4, as it is given minus 1.4 should be equal to 0. So readjust the equation, V2 minus V1 divided by 5 is equal to 1.4. So it is 5V2 plus V2 minus V1 should be equal to 5 into 1.4 will come around 7. So it is minus V1 plus 6 V2 is equal to 7. So this is, we'll get the equation number 2. So we have now equation 1 and 2. We need to solve it for getting V1 and V2. So these two equations we can solve by using simultaneous equation solving or by using matrix method. It's up to you. But for me, I will prefer to solve by matrix equation. So I'll write it as matrix form minus 1. Write the coefficient of V1 and V2, 6. So we will be getting like this. This into V1, V2 should be equal to 31, 7. Now get the determinant of the first one. 7 minus 2 minus 1, 6. So it is 7 into 6 minus 2 into minus 1. We are getting it as 40. Similarly, calculate delta 1 and delta 2. So for getting delta 1, we have to replace this by 31 and 7. For getting delta 2, we have to replace the second column by 31 and 7. And we will be getting it as 200, delta 1 200, delta 2 80. Now V1 we will be getting as delta 1 by delta, it is 5 volt. V2 delta 2 by delta, it is 2 volt. And V5 ohm will be V1 minus V2. It will be 3 volt. It is from across 5 ohm resistor. Thank you.